Welcome back to the deep dive. Today we're taking a really close look at the foundational concepts of GNU Linux, especially thinking about anyone who's maybe curious about it or perhaps even studying for the Red Hat Certified System Administrator certification, the RHCSA.
Yeah, that's a big one.
And this isn't just about, dry tech specs. We're talking practical skills, career paths.
Big opportunities there.
Exactly. And how these sort of open source ideas actually power so much of our digital world, from like your phone to massive data centers.
It's pretty much everywhere.
So whether you're just curious, maybe prepping for a meeting, or need a quick way to get up to speed on this field, well, this deep dive is your shortcut. You'll be well informed.
And we've pulled together some great material for this. It's based on a pretty comprehensive guide covering 8 key concepts for really mastering the RHCSA.
Right.
Our goal here is to pull out the really important bits, the nuggets, so you get both the theory and some genuinely practical insights.
Okay.
We'll touch on everything, from the philosophies behind it all to hands-on stuff, career paths, even how companies save money using this tech.
Right.
And what's really fascinating, I think, is how these fundamental concepts, they truly underpin just so much of modern IT. Tiny devices, massive cloud systems. It's all built on this.
Okay, let's jump in then. First up, free software and open source.
Yeah.
And when people hear free software, they often think it just means, well, free of charge, right? Like free beer.
Yeah, that's a super common misconception.
Yeah.
But the free software, as the Free Software Foundation defines it, it's really about freedom. User freedom.
Freedom. How so?
It means you have the freedom to run the program however you want for any reason. Freedom to study how it works.
Look under the hood.
Exactly.
Yeah.
And change it to do what you need. Then there's the freedom to redistribute copies, and crucially, the freedom to distribute your modified versions too. It's about user control, keeping knowledge open.
That is a powerful idea. So how's that different from open source? We hear that term all the time too.
Right. They often overlap in practice. A lot of software is both. But the open source initiative, they define open source with a slightly different angle.
Okay.
Their focus is more on the practical benefits you get from that open development model, things like better collaboration.
More eyes on the code.
Precisely.
Yeah.
Which often leads to more secure, more reliable software. And it fosters innovation, through that community effort.
Yeah.
So while they often describe the same software, the philosophy is a bit different. Free software is ethics first, user freedom. Open source emphasizes the practical development advantages, efficiency, even commercial benefits.
And these aren't just like abstract philosophical points, are they? They get embedded right into the system through software licenses, things like the GPL.
Oh, absolutely. That's where it gets really practical. The GNU General Public License, the GPL, is a classic example of a free software license using something called copyleft.
Copyleft?
Yeah. It basically means if you modify and distribute software that's under the GPL, your new version has to be licensed under the same GPL terms. It's designed to keep the software free in that freedom sense.
So it prevents someone taking it, changing it slightly, and then making it proprietary.
Exactly. It ensures those freedoms persist. Now, contrast that with permissive licenses like MIT or BSD. They're much more flexible.
How so?
They basically say you can do almost anything with the code, including incorporating it into your own proprietary closed source products without having to share your changes under the same terms.
Okay, so quite different implications.
Huge difference. And for someone studying for the RHCSA, understanding this isn't just about legal stuff, it affects troubleshooting, how you integrate software, performance, even how you might contribute back. It's fundamental.
So it really dictates what you can do and sometimes what you must do with the code. And this whole philosophy, these licenses, they're the bedrock of Red Hat Enterprise Linux too.
Completely. Pretty much all modern GNU Linux systems, RHEL included, are built on these principles, the Linux kernel itself.
The core.
Yeah. And all those essential GNU tools, Bash, CoreTools, GCC compiler, even newer things like System for System Management, they all come from this open, collaborative world.
And for a business, what's the value proposition there?
Yeah, massive value. It means avoiding vendor lock-in, for one. Better security, because leveraging a global community. Think about Red Hat itself. They contribute heavily back to projects like the Linux kernel, Podman for containers, Ansible for automation. It's a two-way street.
Okay, that naturally leads us to the next big topic. distributions or distros.
Mhm.
There are so many out there. What actually is a distro at its heart?
Good question. Fundamentally, a GNU Linux distribution is a complete operating system package. It takes the Linux kernel,
The engine.
right, and combines it with a whole collection of GNU utilities and other software. The shell, libraries, compilers, system services, applications. That's why the term GNU Linux is sometimes used to emphasize that combo.
So it's the kernel plus all the tools needed to actually use it.
Exactly. The distro bundles all that together into something cohesive and usable. And where they really differ is often in their target audience, their philosophy, and importantly, how they manage all that software.
Okay, so let's try and categorize them a bit. You've got ones for big business, ones for developers.
Yeah.
How do they break down?
You can sort of group them, yeah. For the enterprise world, you've got RHEL, Red Hat Enterprise Linux. It's all about stability, long-term support, rigorous testing. Businesses rely on it.
The dependable workhorse.
Pretty much. Then you have major community distributions. Debian is famous for its stability and huge software library. Ubuntu, which is actually based on Debian, is known for being user-friendly and also has long-term support options. Very popular. For developers or people who want the latest stuff, there's Fedora. It's kind of the testing ground for future RHEL features, so it's cutting edge.
So faster updates, newer software.
Definitely. And then for more advanced users, people who really want to customize everything, you have distros like Arch Linux. It's a rolling release, meaning constant updates, and you build it up yourself. Takes more technical know-how.
You mentioned software management being a key difference.
Yeah.
Can you dig into that RPM versus DEB, for instance?
Ah, yes. Crucial for any sysadmin. Package management systems are how you install, update, and remove software reliably. It's vital for maintenance and security.
So two main camps.
Broadly, yes. You have RPM-based systems used by Red Hat, Fedora, CentOS Stream, Alma Linux, Rocky Linux. They use tools like DNF or the older Yum. They're known for being robust, handling complex dependencies well.
And the other.
That's the DEB package format used by Debian, Ubuntu, and many others. Their main tool is apt. It's known for having vast software repositories and being generally very easy to use.
And an RHCSA really needs to know the RPM side inside out.
Absolutely. Understanding DNF, managing repositories, handling dependencies, verifying packages, that's core RHCSA stuff. But knowing about apt is useful too, as you encounter different systems. And beyond packages, distros also differ in things like the default desktop environment, GNOME, KDE, Xbase, and the init system, like systemed, which manages services. All these affect how you administer the system.
Right. Lots of layers. Okay, let's shift gears to something absolutely fundamental. The shell. The command line. Even with graphical interfaces everywhere, this is still critical, isn't it?
Oh, absolutely critical, especially for system administration and automation. The shell is your direct line to the operating system. It takes your commands and tells the kernel what to do.
So for an RHCSA, command line skills are non-negotiable.
Totally non-negotiable. Many essential tasks, particularly managing remote servers or automating things at scale, you only do through the shell. Often it's the only interface available. It's faster, more powerful, and scriptable in ways GUIs just aren't.
And the main shell we need to know, especially in the Red Hat world.
That would be Bash. BASH, the born-again shell. It's the default on the vast majority of GNU Linux systems, including RHEL.
What makes Bash so popular?
Well, it's got powerful features administrators rely on, things like command history, being able to recall previous commands easily,
Saves a lot of typing.
and mistakes. Tab completion is huge too. Start typing a command or file name, hit tab, and it finishes it for you or shows options, reduces typos dramatically. Then you have aliases for creating shortcuts and critically powerful scripting capabilities.
Scripting. That's where the real automation power comes in.
Exactly. Bash scripting lets you automate repetitive or complex tasks. You can use variables, conditional logic, if-then statements, loops, functions, write little programs to manage the system.
Are there other shells worth knowing about?
Bash is the main one for RHCSA, but you might encounter ESH, the original Bourne shell, sometimes used for compatibility. There's Quiche and TCEsh with a C-like syntax. Quiche, the Corn shell, is sometimes seen in older enterprise environments, and Zesh, Z-shell, is popular with developers for its advanced features and customization. But focus on Bash first.
So beyond just running basic commands, What are the essential shell skills for automation?
You need solid navigation and file manipulation skills, of course, but then really diving into scripting is key. Understanding how to write, test, and debug shell scripts is what elevates you.
For tasks like,
Oh, automated backups, adding batches of users, checking system health, deploying applications, anything you do repeatedly. A good script saves enormous amounts of time and, importantly, reduces the chance of human error.
right consistency.
Precisely. And then there's scheduling. Tools like cron are vital. Cron lets you schedule your scripts or commands to run automatically at specific times, daily, weekly, whatever. Essential for routine maintenance, log rotation, things like that. Mastering the shell and automation is really a core part of being an effective sysadmin.
Okay, so we've talked distros, we've talked shells. This brings us to a really practical point. Choosing the right Linux distribution. It sounds like a strategic decision, not just personal preference.
Oh, it's definitely a strategic decision, especially in a business context.
Yeah.
Picking the right distro is a vital skill. There's no single best one. It always depends on the specific requirements.
What are the key factors you'd weigh up?
You'd look at stability. How reliable does it need to be? Security requirements, performance needs, what hardware is it running on, compatibility matters, and critically, what kind of support is needed? Community support, paid vendor support.
So an RHCSA needs to be able to analyze those needs and recommend something.
Exactly. Be a consultant, almost. Weigh the trade-offs.
Let's take some examples. For a big company running critical servers, what's likely the best fit?
In that scenario, RHEL is very often the go-to choice. Its reputation is built on high reliability, predictable performance, long support life cycles, extensive documentation, and that certified vendor support. For critical systems, data centers, production environments, that stability and support are paramount.
Okay. What about the other end, say, a developer workstation or a testing environment where you want the latest tools?
That's where Fedora really shines. It's cutting edge, gets new features quickly, and serves as that upstream testing ground for RHEL. Great for experimenting, trying out the latest software versions. The trade-off is shorter support cycles, so you wouldn't typically use it for a long-term stable server.
Makes sense. What about those popular community options like Debian or Ubuntu? Where do they fit best?
Debian is legendary for its stability and strong commitment to free software principles. It's an excellent, super reliable choice for servers, especially if you don't need that commercial RHEL support. Ubuntu, built on Debian, adds a layer of user-friendliness and has those regular long-term support LTS releases. It's very popular for desktops, cloud deployments, and even some enterprise use where paid support isn't the top priority.
And for the real tech enthusiasts, the hobbyists, Arch or Gentoo.
Yeah, those cater to a different crowd. Arch Linux gives you immense control with its rolling release model and minimalist approach. You learn a ton setting it up, but it demands more technical skill to maintain. Gentoo goes even further, letting you compile everything from source code for maximum optimization. Very niche, high learning curve.
So the key takeaway is assess the mission.
Absolutely. And RHCSA needs to understand these differences, weigh the pros and cons, stability versus cutting edge, support needs, user skill level, and align the distribution choice with the actual goals of the system or the organization.
This leads perfectly into career paths. With GNU Linux being so widespread, getting RHCSA certified sounds like it opens quite a few doors.
It really does. The demand for Linux skills is consistently high because it powers so much critical infrastructure, servers, cloud, embedded systems, you name it.
So the certification is valuable because
Because it's performance-based. You have to actually do the tasks in a real environment during the exam. Employers know an RHCSA can genuinely manage Linux systems hands-on. It validates practical skills, making you a very attractive candidate.
What kinds of roles are we talking about?
Common ones include system administrator, obviously, but also DevOps engineer, cloud administrator, Linux support technician, roles that involve managing users, securing systems, handling storage, network configuration, and crucially, automation.
And where do people with these skills work? Is it still mostly traditional data centers?
Some, sure, but the landscape has shifted massively. Cloud computing is huge, and Linux absolutely dominates cloud servers. So, skills in virtualization, containers like Podman, which is big in the Red Hat world, and orchestration platforms like OpenShift are incredibly valuable.
And DevOps. That seems like a natural fit.
A perfect fit. DevOps relies heavily on automation and infrastructure as code. Strong shell scripting skills, plus expertise in automation tools like Ansible, which is a major focus for Red Hat, puts RHCSAs in a prime position for DevOps roles, helping bridge the gap between development and operations.
Any opportunities outside of big companies? Freelancing, maybe?
Definitely. There's a solid market for freelance or consulting work, especially helping small and medium businesses that need Linux expertise but maybe can't afford a full-time admin. Things like system hardening, performance tuning, migration projects, lots of possibilities. The bottom line is the RHCSA proves you have skills vital for keeping modern IT systems stable, secure, and running efficiently.
Okay, so we know it's valuable for careers. Let's flip to the organizational side. How does using GNU Linux and free software actually save businesses money? It seems counterintuitive sometimes.
It's a great question, and the savings are real and multifaceted. The most obvious one is licensing costs.
No per-user fees.
Exactly. Most GNU Linux distributions and free software are available at no charge for the software itself. Compare that to proprietary operating systems or applications that can have hefty per-server or per-user annual fees. Even with enterprise distros like RHEL, where you pay for support, it's often far more cost-effective, especially when you scale up. You're paying for value-added service, not the bits themselves.
That makes sense. Direct cost avoidance.
Hmm?
What are some less obvious financial benefits?
Flexibility and customization are huge because you have the freedom to modify the source code.
The freedom aspect again.
Right. You can tailor the software perfectly to your specific business needs without waiting for a vendor or paying them for custom development. You can also optimize it, maybe strip out components you don't need, which allows systems to run effectively on older or less powerful hardware.
Extending hardware life, delaying upgrades.
Exactly. That saves significant capital expenditure. Then there's security.
How does open source save money on security?
Well, the transparency means many eyes are looking at the code. Vulnerabilities tend to get found and fixed quickly by the community. This reduces the risk of costly security breaches, data loss, and potential compliance fines. Plus, many excellent security tools are themselves free software, lowering the cost of securing your infrastructure.
Okay, so lower risk, lower tooling costs. What about day-to-day operations?
That's where operational efficiency comes in. Automation tools, again, think Ansible, are often free software and incredibly powerful. They let admins manage potentially thousands of servers with far less manual effort.
Streamline deployments, patching.
Yes, all that stuff. It dramatically reduces labor costs associated with system administration. And the inherent stability and reliability of well-managed Linux systems mean less downtime. Downtime costs businesses real money in lost revenue and productivity, so reducing that is a major saving.
Any other angles? Community.
The community aspect is financially significant too. Organizations benefit from shared development costs. They're not funding R&D all by themselves. They can influence software direction by participating. And there's a large pool of skilled Linux professionals available, which can lower recruitment and training costs compared to more niche proprietary tech. It all adds up to greater long-term independence, predictability, and the ability to invest resources in innovation instead of just keeping the lights on.
It's clear certifications like RHCSA are valuable. What about looking beyond it? If someone gets their RHCSA, what are the next steps or other paths to certify their success?
RHCSA is a fantastic foundation proving those core hands-on skills. The natural next step within Red Hat is often the RHCE Red Hat Certified Engineer.
How does that build on RHCSA?
RHCE goes deeper into more advanced administration tasks and, crucially, has a very strong focus on automation, specifically using Ansible. It signals a higher level of expertise, especially in automating infrastructure management, which is huge in enterprise settings.
Okay, so RHCE for deeper Red Hat skills. What about vendor-neutral options?
Good point. The Linux Professional Institute, LPI, offers respected certifications like LPIC1 and LPIC2. These are distribution neutral, meaning they cover core Linux skills applicable across different distros, command line, networking, security fundamentals. They give you broader marketability.
And the Linux Foundation, they're big players too.
They are indeed. The Linux Foundation has their own certs like LFCS, Linux Foundation Certified Sysadmin, and LFCE, Certified Engineer. These are also distro-neutral, focusing on practical skills needed in modern environments. Plus, LF has really expanded into specialized certifications for newer tech.
Like Kubernetes.
Exactly. Kubernetes, containers, cloud-native technologies, these are very relevant today. And beyond the big OS certs, you can get certified in specific, often open source, tools Git for version control, Jenkins for CI/CD pipelines, Ansible itself, various security tools and frameworks.
So why bother with all these certs? What's the real value?
For you, the individual, they formally validate your skills to potential employers. They show you're committed to learning and keeping current, which is vital in tech. They also provide a structured way to learn and ensure you cover the important areas. In a competitive job market, they can definitely give you an edge.
Okay, great overview. To help bring all the distro talk together, maybe we can do a quick reference recap, just a snapshot of the main ones we discussed.
Sure, a quick summary can be useful. It really highlights the range of choices.
So top of mind for enterprise.
RHEL Red Hat Enterprise Linux. Stability, security, long-term paid support. The go-to for critical business systems.
And RHEL-like community options.
You've got CentOS Stream, which is sort of a rolling preview of RHEL, and then Alma Linux and Rocky Linux, which aim for direct RHEL compatibility, offering stable, community-supported alternatives.
Solid server choice, maybe less corporate.
Debian. Rock-solid stability, huge repositories, strong free software roots, excellent server OS.
User-friendly all-rounder.
Ubuntu. Based on Debian, easy to use, great community, popular on desktops and servers, especially cloud, has those LTS releases.
For the developers wanting the latest.
Fedora, cutting-edge features, fast updates, the upstream for RHEL, great for testing and development.
And the power users, the tinkerers.
Arch Linux, rolling release, highly customizable, minimalist philosophy, steep learning curve, but very rewarding.
Any other notable ones?
OpenCSE is worth mentioning, with its stable, Leap, and rolling tumbleweed versions, popular among sysadmins and devs, and Gentoo for extreme customization via compiling from source.
So lots of flavors.
Absolutely, and understanding these basic characteristics, stability, target user, package management, support model is really key to making smart choices, whether it's for your own laptop or designing a company's infrastructure.
Well, there you have it. You've just taken a deep dive into the core concepts that really underpin a huge chunk of the modern digital world. Hopefully, it's given you a powerful shortcut to being genuinely well-informed on GNU Linux fundamentals. We've touched on the philosophies, the different distros, the power of the shell, how to choose the right system, career paths, and even the financial side for businesses.
Yeah, it's a broad landscape, but those core ideas connect everything.
So maybe a final thought to leave everyone with, something to mull over.
Okay, how about this? We've seen how deeply ingrained free software and open source are in everything from critical infrastructure to the latest tech trends. Thinking about that core philosophy, the freedom to share and modify, how might that collaborative, open approach continue to shape things beyond just software? Could it influence how we approach problem solving or innovation in completely different fields we haven't even considered yet?
That's a fascinating question, something to definitely chew on. Thank you for joining us on the Deep Dive. Until next time, keep exploring, keep learning, and keep diving deep.